Hi everyone and welcome back to my channel in Economist. So in the previous video, we have started off with a problem set on time series analysis and forecasting, where we were solving this ISI JRF Economics 2023 paper, question number 5. And we have already solved part 1 of this question in the previous video. So if you haven't watched that video, please check that out. And in this video, we'll be solving part 2 of this question and we will finish off with this problem set, right? So let's take a look at this part. It says that yt is a time series process which is now given by this. Yt equals to phi yt minus 1 plus epsilon t plus theta epsilon t minus 1, where epsilon t still follows a white noise process with mean 0 and variance sigma square. Not only that, mod phi is less than 1, this criteria holds. And also now mod theta, this value is also less than 1. What you have to do, you have to find out the autocorrelation function of the process yt and draw the correlogram plot for the process when phi equals to 0.6 and theta equals to 0.4. So what is correlogram? Correlogram is basically if you plot lag values on one axis and the row values on the other axis, that is the autocorrelation basically. Autocorrelation function on the other axis, the plot that you will get will be the correlogram that we have to find out, right? So this is the agenda for this video. Now, if you look at this function that is given, the time series process that you given to you, can you pause the video and think which kind of process is this? Is it AR? Is it MA? Is it ARMA? Is it ARIMA? Also, we have discussed all of these things in the time series playlist. If you are someone new to my channel, I'll give the link in the description. I have all the theory videos covered already. So if you are not familiar with this, you can check that out, right? So please pause the video and think what kind of function is this? If it is an ARMA function, ARMA process. And what is the order of that? What is the order? Order is 4, 1. So maximum lag value for the AR part is 4 and the maximum lag value for the MA part is 1. So it is ARMA 4-1 process. Now let's move ahead and try to solve this question, right? So this is part B or part 2 of this question. So yt is given to you as phi yt minus 4 plus epsilon t plus theta epsilon t minus 1, where mod phi is less than 1, mod of theta is also less than 1, and this epsilon t follows white noise process with mean 0 and a variance of sigma square. Now, firstly, what we will do, look at this. If mod phi is less than 1, then from the properties of ARMA, what we can say is that the process yt is covariance stationary. Process yt is covariance stationary. Again, I'm saying that I have covered these concepts in the theory videos that is already been there. Please check that out if you are, you don't understand how these things are coming, right? So MA process is always stationary, whatever lag it is. MA is always stationary, and this AR portion is stationary only when this mod phi is less than 1. That is why the entire process becomes covariance stationary if the the parameter here, this phi parameter has an absolute value less than 1. Now, if this is covariance stationary, what we can say is that we can say expected value of yt is exactly equals to expected value of yt minus 4. Suppose this value is mu. This is the first step. Now, if you take expectation on both sides of this process, what you will get, expectation of yt will be phi expectation of yt minus 4 plus expectation of epsilon t plus theta expectation of epsilon t minus 1. This is what you will get. Now, expectation of yt is mu. This is phi. Expectation of yt minus 1 is also mu due to the process is covariance stationary. Expectation of epsilon t is 0. See here, this from this distribution, expectation of epsilon t minus 1 is also 0 because this suffix doesn't matter. This is white noise. It is non-autocorrelation is present. Covariance of epsilon t and epsilon t minus j is absolutely 0 for all j basically. Now you can take this side. So ultimately what you get is that this new value will be absolutely equals to 0. Right? So this is step 1 in solving this particular question. Now, if you have this information, what you can say about yt minus mu? Mu is absolutely 0, right? Mu is absolutely 0, so only the right hand portion will be there. Sorry, let me write it down. So this will be yt minus 4 plus epsilon t plus theta epsilon t minus 1. Now, you multiply in order to find out the autocovariance function first. To get autocorrelation function, you need to first find out autocovariance function. How do you get that? Simply multiply this with yt. Simply multiply this by this yt minus h minus mu on both sides. So yt minus 4 plus epsilon t plus theta epsilon t minus 1 into yt minus h. So what I have done here, multiply by yt minus h minus mu on both sides. This is what I have done. Now take this multiplication. So the left hand side will be what? It will be simply gamma h. This we have done multiple times, so I am not explaining to you. So basically we are taking expectation on both sides. If you take expectation, this will be simply gamma h, and the expectation on the entire side will give you phi. Expectation will be on both the terms, all the terms individually. So this is the first term. Then you have expectation of epsilon t yt minus h. Then you have expectation of epsilon t minus 1 y t minus h. So expectation of this is gamma h, that is why it is gamma h. Then phi. Now how do you explain this particular thing? The thing is, here take the suffix into account, t minus 4, and then minus of the next suffix, which is t plus 4. So this suffix minus this suffix will give you the gamma. Now plus. Can you say what is this thing? This will be absolutely equals to 0 for all age greater than 0. This also we have explained multiple times. And then you have theta into, what is this? Expectation epsilon t minus 1 and yt minus h. And this will be only 0 if, what will be the restriction? If age is greater than 0, right? Age is greater than 0. So we know by the property we know expectation of epsilon t yt minus h is absolutely equals to 0 for all age greater than 0, and the same concept is used here. From that, what you can say, gamma h is simply phi of this t, and t here goes out, h minus 4, and this will happen only when h is greater than 1. So see, this is 0 when h is greater than 0, this is 0 when h is greater than 1. So combining these two terms, you can say when h is greater than 1, both of them are 0. That is why this is the restriction. So this is the general form of your autocovariance function for this given ARMA 4-1, right? So now you can, change the value of age and see what will happen for different conditions. So we have gamma h equals to phi gamma h minus 4 when h is greater than 1. So basically change the value, h is greater than 1. So suppose h is 2. So in that case, this will be gamma 2 only. See, gamma h is equals to gamma of minus h when the process is covariance stationary. This condition holds when the process is, I have, proved this thing also in the theory videos. So please check them, that this thing will hold. So gamma minus 2 is simply gamma equals to 2. So gamma 2 will be exactly equals to 0. Now, if it is 3, then gamma 3 by this, relationship, phi gamma, this will be 1. Similarly, if you put gamma equals to 4, it will be gamma 0. And like this, you can continue doing that. Gamma 4 equals to 5, gamma 1. And you can continue in this particular fashion. Let me write h equals to 6 also. h equals to 6, gamma 6 will be phi gamma 2, and so on and so forth. You can continue doing this thing. So what we can see here is that gamma 2, we have got this to be 0. And by the recursive relationship, you can find out all these successive autocovariance terms. But here the restriction is h is strictly greater than 1. So we don't know two terms. First is what will happen when h equals to 0 and what will happen when h equals to 1. So these two things we need to manually find that out. And if you know this, then you can substitute this here, 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 and then get the rest of the terms, right? So let us see manually what will be the value of gamma naught. So in order to find this out, what you can simply do, take yt minus mu is already with us. See, yt minus mu, we have already found out what it is. So again, multiply it with yt minus mu. So basically, we are taking square of this. And mu is 0. So basically, both sides we are multiplying by yt. So it will be phi yt minus 4 plus epsilon t plus theta epsilon t minus 1 into yt. Now again, if you take expectation on both sides, it will be phi expectation of yt minus 4 plus expectation of epsilon t yt plus theta expectation of epsilon t minus 1 yt. Now what is this? What is this? This is simply gamma naught. This is the variance. Now phi, this will be what? Take the suffix into account, t minus t plus 4. So it will be simply gamma 4. Plus, here you have these two terms which you have to enumerate, right? So let me write it as it is. We have to simplify this thing further to see what we get. We'll do this in the next line. So let us find out. Let us find out what will be expectation of firstly this thing and then this thing. So expectation of yt epsilon t. What will be this? So expectation of epsilon t, and instead of yt, you can write this original function. So this will be simply phi of yt minus 4 plus epsilon t plus theta epsilon t minus 1. This is the original function. If you take expectation on individual terms plus expectation of epsilon t whole squared plus theta expectation of epsilon t minus 1. So the first term is obviously 0. See, this is coming from directly this proposition. Expectation of epsilon t yt minus h is 0 whenever h is greater than 0, which is satisfied here. So this term is 0, right? This term is 0. Now the second term, it is expectation of epsilon t square, because epsilon t follows white noise, it means 0. Variance is sigma square. So variance of this is nothing but the variance of epsilon t, which is sigma square. And then this term is again 0 because the non-autocorrelation. Epsilon t follows white noise, so the autocovariance will be absolutely 0. So this term is entirely sigma square. Now in the similar fashion, we need to find this term also, expectation of epsilon t minus 1, and you have yt. So expectation of epsilon t minus 1, again instead of yt, substitute the value phi yt minus 4 plus epsilon t plus theta epsilon t minus 1. So phi expectation of epsilon t minus 1, t minus 4 plus expectation of epsilon t minus 1. And then you have plus theta expectation of epsilon t minus 1 and a whole square of that. Now, this first portion is phi expectation of epsilon t minus 1, t minus 4. Again, this will come out to be 0 by this similar logic. And this thing is again 0 due to non-autocorrelation and epsilon t for white noise process. And the final thing is that theta into, this is basically variance of epsilon t minus 1, which is sigma square. So this will come out to be theta sigma square, right? So now we have all the components. We can basically combine them together to find out what is the value of gamma naught. So gamma naught is simply, first term is phi gamma 4. See here, this is phi gamma 4, and then the second term is sigma squared, and the third term is theta square and sigma square. So this is what we have. So this is basically gamma naught. Now, how do you find out this individually? What is gamma 4 and gamma naught? There is a relationship that we have established here. See, gamma 4 is simply phi gamma naught. So gamma 4 is simply phi gamma naught. Now phi into, instead of gamma naught, you can put this phi sigma square plus 1, sorry. You can simply write phi gamma 4 plus sigma square plus theta sigma square. So basically this is theta sigma square. Now this is basically phi square gamma 4. So I know this thing might seem a little, complicated, but it is a 25 marks question, so it has to involve a lot of derivation. We can't do anything about that. So it will be 1 plus theta. Right? So basically gamma 4 will come out to be sigma squared 1 plus theta, and then you have 1 minus phi squared. Now if you put this into this expression, gamma 4 value, gamma naught will come out to be something like this. You can basically check the steps if you find anything difficult and let me know, right? So this is what is gamma naught and this is what is gamma 4. In the similar fashion, you can find out what will be gamma 1. How do you find out that? It will be simply expectation of yt minus 1. So basically this is covariance of yt and yt minus mu, and then you have, or basically expectation of yt minus mu and then expectation of yt minus 1 minus mu. Basically this expression, by exactly the similar process that we have followed, you can find this out, and I have already done this for you. The expression that you will get for gamma 1 is something like this. You can check this in your free time. This will be the expression of gamma 1. Now again you have a relationship between gamma 3 and gamma 1 here. See, gamma 3 and gamma 1 have a relationship. If you use this relationship, gamma 3 will come out to be phi theta sigma square upon 1 minus phi square, and gamma 1 will be phi squared theta sigma squared 1 minus phi squared plus theta sigma squared. So now you individually have all the values. What is gamma naught in terms of phi and theta? You have what is the value of gamma 1 in terms of phi and theta. You have the value of gamma 2 again in terms of phi and theta. Gamma 3 value in terms of phi and theta. Gamma 4 in terms of phi and theta. And if you have all these values, you can use this recursive relationship here. 5, 6, 7, 8, 9, 10. So you can recursively use this relationship to find out all the autocovariance functions, right? So this is how you solve this entire thing. You have to use the recursive relationship to solve this. Now, if you get back to the question they have asked you, what they have asked you is that find out the autocorrelation function and draw the correlogram plot when phi is 0.6 and theta is minus 0.4. So now if you apply these values, phi is 0.6 and theta is minus 0.4. If you use these values in the relationships that you have got, Basically, since see everything is a function of phi and theta, so you can apply this phi value and the theta value in every relationship that you have. I have done this for a few things. So gamma naught will be zero point 0.6 and then sigma square, then you have zero point 0.6 upon 1 minus zero point 0.6 whole square, and then you have 0.6 sigma square. So in this fashion, you will put this phi value and theta value for all these expressions that we have derived. This will come out to be 1.1625 sigma square. You can check this on your free time. In the similar fashion, you will find out what is gamma 1. Gamma 1 will come out to be 0.225 sigma square, and gamma 2 is 0, what we have got in the previous case. In the similar fashion, you can do this for gamma 3, gamma 4, gamma 5, and all the remaining things, right? So this is the same thing. I am not showing you the calculations, but this is how you have to show this. Now, if you have individual values for gamma naught, then you can simply find out what is rho. That is the autocorrelation function. This will be simply gamma h upon gamma naught. This is the simple formula that we use for covariant stationary processes. So this will be simply rho h, rho h. So rho h value, it will come out to be 1 when h equals to 0. This is true for every process that you take. Now for h equals to 1 and minus 1, what you will do, you will take the gamma 1 value which we found out here. This is, sorry, this is the gamma 1 value that you have found out here, and this is the gamma naught value. So simply you will take the ratio. So rho 1 will be simply gamma 1 upon gamma naught. You know the value of gamma 1, you know the value of gamma naught, take the ratio, you will get as I have got this value to be 0.1935. Right? You will get something like this. Similarly, you can do this for 2 plus 2 minus 2 plus 2 minus 2. This value will come out to be 0 because gamma 2 is 0. Gamma 2 value is 0. So 0 upon anything will be 0. And you can do this for the rest of the terms. When h is 3 minus 3, when h is 4 minus 4, you will get some specific values, right? You can write this in this particular format. So this is the required autocorrelation function that we needed to find out. Now all we need to do is to plot it in a correlogram. So correlogram is a diagram which basically looks like this. Let me try to show this. This is a line, and then what you have, this is another line. Let me, right, and you have this line here. So on one axis, what we do, on one axis, we measure the lags. On one axis, we measure the lags. Here you have this axis. On this axis, we measure the correlation, autocorrelation function, which is this, right? Now for 0, then 1, then 2, for 3, for 4, and here you have -1, -2, -3, -4. So it will continue from minus infinity to plus infinity. This will continue, and here you have the negative values. For negative values, this axis is there. Now, how do you plot this thing? Simply take the correlation function. When h equals to 0, rho h is exactly equals to 1. So here you see this is the h equals to 0. So rho h here will be exactly equals to 1. So this will be 1 point. This is 1 point in the correlogram diagram. Now for the second point, see when h equals to 1 or -1, it is minus 0.19. So it will be in the negative side. Sorry for that. So it will be in the negative side. Suppose this is the point. So corresponding to this value 1. So here you will have one correlogram, and here you will have one correlogram corresponding to the value of 1. This will be the point, this will be the point. So correlogram will be here, this vertical line. Vertical line is the correlogram. Here this vertical line is the correlogram. Now similarly for h equals to 2 and -2. for 2 and minus 2, the values are exactly 0. So this point and this point. And similarly, you can compute what will happen for 3 minus 3, 4 minus 4, and you will plot it in a diagram like this, right? So this is the correlogram diagram for our required problem, and this is how you solve this entire problem, right? So see, all the parts are covered, and this is how you solve both the parts of this question. I hope you like this video and you find this helpful. If you have any doubts, if you don't understand any of these steps, you can let me know in the comment section. And this question is directly from the JRF Economics examination conducted by ISI from the paper 2023. If you want to see more solution videos like this, you can also write that below in the comment section. And I'm planning to make a entire workbook consisting of all the past year questions along with their solutions. If you're interested in that, you can also let me know, right? And as of now, please hit the subscribe button and do give me a like. Share this video if you like this, and let's meet you in some other video. Thank you for your time.